So, come back here and see if one of those no-name papers is yours. All right, so remember that our test looks just like this, right? So you're going to have a page of graphs on your test. It may not be the first page, but there'll be a page of graphs on your test. So here is the relatively simple little picture that we're starting with. And we are going to graph negative 2f of x. Now, who can tell me what changes this is making to the picture? I'm going to raise it up a little bit. Who can tell me what difference we're going to have in words? Tell me what difference we're going to have because we put negative 2 out there in front.
Upside down.
Upside down, for sure, it's going upside down. What else is happening? Height is twice as tall. So twice as tall. Okay, so here we go. I'm going to take my little triangle right here, and I'm going to flip him up. But in the beginning, he came down 2, so now he's going to go up 4. So on your graph paper, that is easy. He's going up 4. Now my trapezoid is up 3, so he's going to go down 6. So look, see this point right here on the original is over 2, up 3. Well, now you're going to go over 2, down 6. Over 4, down 6, and back to the axis. So that's a picture of a Anybody have a question about that? All right, let's look at the next one. What's happening here? Let's put it in words first. What is changing because of all this? It's going to be bottoms up. So this is our bottoms up transformation, which basically with this given picture simply means the triangle's coming up. And then what does this do? Down 2. So I'm going to do that in 2 steps. You're free to do it in 1 if you wish. Nothing is changing size. Everything, nothing's getting stretched or shrunk. It's staying exactly the same size. So this triangle, though, is bottoms up. So he's coming up. Trapezoid's staying up. 1, 2, 3, 4, 5, 6. Okay, that's the bottoms up part. Everybody still got good with that? Now I have to take that though and drop it down 2. So down 2. And on your graph paper, that's easy. Every point down 2. So drop every point just down 2 blocks. Anybody have a question about that? Kayla, you with us? Okay, don't forget to drop it down too, okay? All right, next. In words, you can tell me how this one's changing.
Flips
sideways flip. This is a sideways flip. If you don't know the rules, guys, spend some time learning those. We gotta know that that means sideways flip. And then this means up one, just like this meant down two. All right, now sideways flip is bothering some of you, I can tell from the quiz. What sideways flip means, guys, is if I was on the left originally, I'm going to the right. It doesn't tip me upside down or do anything weird. It just says if this triangle in the original picture went left one, down two, he's gonna go right one, down two. So the triangle flip-flops over this side. And then the trapezoid, that first point right there, went right two, up three. He's gonna go left two, up three. That is a sideways flip. Look at that, make sure that's registering. Because what I saw in some of your quizzes was a little whopper jaw. Now, is that okay, everybody? Now we're gonna go up one. So every point is up one block. Does anyone have a question about that? Alrighty. Anybody tell me what happens here? This is the mirror one. So I don't know. Mirror right side onto left. So what that means is, look at your original picture and draw the right side of the picture. Draw this right here, exactly the way it is. So don't change a thing. Draw it exactly the way it is. There it is, trapezoid. Now, once you get that drawn, take that exact picture and draw it again on the other side. So mirror it over to the other side. And that's it. And that's all we're doing with that one. Any question about that one? Got that one down? Then the last one. Who knows what to do with this one? Divide the width. Very good. So divide the width. So what that means simply is this. How wide is this triangle? 2. We're going to divide it by 2. So now you're going to draw that triangle, but it's only 1 block wide. That number divides the width. So instead of being 2 wide, now it is only 1 wide. How about the trapezoid? How wide is it originally? Count the blocks. 6 blocks. So now you're going to draw that exact trapezoid but it is only going to be 3 blocks wide. I think we pretty much covered, oh no, one thing we didn't cover in that review section, make sure it's on, yeah, it's on the next one, but we didn't do any sideways moving. How do we do that? How do we move something sideways?
Instead of parentheses.
Gotta put something inside the parentheses like this, right? That would move me to the left. Gotta know all the rules. All right, good on that, folks? Page 1? Ooh, page 2 is our word problems. There are 4 kinds of word problems on this test. They're all right here. So the first one is our box. Parts of this, you guys, don't ever change. Parts of this are the same no matter what. So we shouldn't miss this problem. The equation, for example, is always exactly the same except for the numbers of the size of the paper. How is the equation always set up when we're finding the volume of the box? Who remembers?
13.
What'd you say, Sincere?
13 minus 2.
It is 13 minus 2x. And then 9 minus 2x. And then what, Kamari? X. Always, always, always. Now, Sincere used 13 and 9 because those are the numbers in the problem. Whatever the numbers are in the problem, that's what you use here. But it's always number minus 2x, because you're cutting off 2 x's. Number minus 2x, and then x. Okay? We're on our practice test. Those are for later, for another day. So that's the equation. Everybody got it? Now, the next question is, what's the domain? Now, the domain is the 2 numbers that x has to be between. You're going to write it as an interval because that's how we write things in calculus class. But it's what is x in between? Who remembers what I told you about this one? It's always 0. X must be positive. This is a positive number. Now, who remembers what I told you about this one? Half the smallest dimension of the paper. So our paper is 13 by 9. 9 is the smallest, and half of 9 is 4.5. So what you're telling me is x has to be bigger than 0 and less than 4.5. That's what this means. When we go to the calculator now, this becomes our x min, and this becomes our x max. So when we go to our calculator, we're going to set up our window first. Window, top row, window. The only numbers you need to concern yourself with are the mins and the maxes. Don't worry about all the rest of that stuff. So x min is 0. X max is 4.5. What is y min? Always 0. So y min is always going to be 0. That is not a test question, but you need to know that to set it up on your calculator. What about y max?
100.
She says let's start with 100. I'm good with that. We can start with 100. Do you remember from the other day that sometimes that's not big enough? So we just go back and make it bigger if we need to. Okay? Now go to y equals. This is how you graph things. You have to tell the calculator y equals. And then type in this exact equation just the way I wrote it. So parentheses. Oh, shoot. Now when you hit graph, no one really cares what your picture looks like exactly, as long as what? What do you have to see? A mountain and the top of that mountain, right? So as long as you are seeing something that looks like this, you know, mountain, you are good to go. If your mountain looks like this, then you have to make your Y max bigger. But actually 100 worked. I can see the top, can you? So then we second calc max and set your cursor somewhere on the left side of the mountain. Give yourself plenty of room to work. Set it then somewhere over on the right side of the mountain. And then set it somewhere in between those two. And when you hit enter, you should see a point down at the bottom. It says X is 1.74 and Y is 91.44. Now, both of those are not the answer to the question. One of those is the answer to the question. What was the question? Find the maximum volume. Now kids, this is X. X is the size of the corners. This is not the volume. This number is the volume. So the volume is 91.44 cubic inches. Joshua, did you have your hand up?
I was gonna ask, I thought that was the answer.
No. Only one of them is the answer. Now, Joshua, if the question had been, how big are the corners you need to cut out? Then 1.74 would be the answer, because X stands for the corners. Y stands for the volume. So you could be asked either one. Okay? All right. Remember, these are guaranteed test questions, kids, and that one's a guaranteed exam question. Find the final cost of your new uniform pants. If the price tag says $33.50 and there is a 15% discount and there is a 7% tax. What are you doing? Do you have a calculator? Taylor, you can't do this without a calculator. Where is your calculator? Did you put batteries in it? All right. So, I like to, when I do these problems, I write down whatever the original price is, and then I'm going to have a parentheses for every change. So there's two changes being made. If the change is a decrease, then the number that goes in the parentheses is going to be 1 minus the percent. So 0.85. If the number is an increase, then the number that goes in the parentheses is 1 plus the percent, 1.07. And I'll just type that in. And my new uniform pants cost $30.47. Would you agree with that? Now, where did the 0.85 come from? 1 minus 0.15. And the 1.07 was 1 plus 0.07. Any question about that? All right, next problem number 4, we're mixing up cocoa, different, like, you know, strong cocoa and weak cocoa, mixing it together to make medium cocoa. What's our setup for this? Who remembers? We just talked about this a couple days ago. Anybody remember? Little formula we use. Amount times percent plus amount times percent equals amount times percent. And I would go ahead and write that down. It only takes a minute. And then you can see that there are 6 different numbers that need to go into the problem. There are 3% and 3 amounts that need to go into the problem. So the percents should all be there. So we got 45%. Notice I'm putting it in as a decimal, always a decimal, always a decimal. Just like this problem. We don't use 15, we use 0.15, always a decimal. And we have 75% cocoa, and we're gonna end up with 58% cocoa. Does everybody understand those things in those spots? Now there should be one more actual number in the problem. It says 32 ounces of 75, so the 32 goes into the amount with the 75. Does that make sense to you? And then these problems seem to always say how much. And now we gotta fill in a blank back here. We talked about this the other day. Who remembers? 32 plus x, exactly, Hugh. Because aren't these 2 amounts being added together to give me this amount? So if I dump in x ounces and 32 ounces, I'm gonna have 32 plus x. Does anybody have a question about that setup? Because now it's just a matter of solving it. So I'll go ahead and just solve it. You will too, you're gonna help me. Work along with me, since you'll have to do this on your test. Don't forget, this is a distribute, so you're gonna need to distribute that one. This is what I got when I distributed properly. Put all the x's on one side, all the numbers on the other side, and divide it. Did anybody else get 41.85? Did you? Thanks, Jim. question about that? Brennan?
Yeah, where'd you get that 18.56?
I distribute here. This is a distributive. So 0.58 times 32. I mean, I could be wrong.
I got 19.
Okay, take 0.58 times 32. Sometimes your finger maybe gets over on another button or something. All right. Last word problem. Last year the team won 19 games. This year they won 24 games. What is the percent of increase? Okay, tell me, how do we do this? There's a formula for this. There's a formula for all these kinds of problems. Who remembers the percent change, the percent of change formula? Difference over original. Or some of you think of new minus old over old. However you think about it, it's the same thing. It's difference over original. So what's the difference of these two numbers? 5. What's the original? 19. So whatever that is, when you do that division, it's going to give you a percentage. I got 26.3. Kendrick, you with us here? Everybody okay with that one? I heard somebody say piece of cake. Yep, that one is definitely a piece of cake. If you remember your little formula. All right. Now, the next page, I kind of squeezed it all on there. On the real test, this will be spread out on 2 different pages. So if you want to use a different sheet of paper, that's fine. I don't know if you did it on here or not. All right, so here we go. Find, this is number 6. Find a direct algebraic relationship between x and y if x is this and y is this. Okay? Now, here's the deal, folks. A direct algebraic relationship means, right? Actually, let me just say this. It means eliminate t. That's what you gotta do. You gotta eliminate t. Because if you get rid of the t's, all you'll have left is x and y. Are you sick, sweetie? Okay, would you sit back up? You're breaking my chairs. Pull that chair out. Yep. Let's sit up straight. Come on. It's not that bad. We're getting ready for a test. You're gonna do well on this one. All right, so we're gonna eliminate t. Now, who has a thought on how that might happen? Guys, you know how to eliminate. Well, first of all, let me line these t's up. These t's aren't lined up. So x equals t plus 4, and y equals 2t minus 3. So I just flip-flop these, so now my t's are lined up. What could I do to my top equation so that the t's would cancel when I added them? Multiply by -2. So I'm going to multiply the top equation by -2. This is elimination, kids. This is what you've done since your freshman year. You're going to eliminate. So -2x equals -2t minus 8. And y equals 2t minus 3. So I multiplied everything in the top equation by -2. And now what happens when I add my equations together? Don't those cancel? which is exactly what we wanted to happen. Now, be careful with these. You are adding. So negative 2x plus y, those do not add, don't combine them in any way. It's negative 2x plus y equals negative 11. And that's your answer. Because I'm a math teacher, I have to word things like the official way, but just remember that finding a direct algebraic relationship between x and y means eliminate t. So in this problem, I had to line my t's up first because they weren't lined up. But as soon as I got them lined up, then we knew what to do, and there's your answer. Question 7. The question is, are these inverses? Now there are a couple of acceptable ways of doing this. Actually, I think it's 3 off the top of my head. Here's what I think is the easiest way. It's up to you. If you want to do it some other way that you can think of, that's fine. Here's what I think is the easiest way. Okay, Bragg, what is your football number? 9? Okay, so I'm going to find f of 9. So I am just picking a random number, any number you want to pick, and I'm putting it into the first function. What do I get if I put 9 into the first function? 14? Okay, now, whatever answer you got, plug it into the second function. If they are inverses, when you do this, you're going to get your first number back again. We're going to get 9 back again. If we don't get 9 back again, they're not inverses, because inverses flip-flop x and y. So we started with 9 and got 14. Now we're putting 14 into this one. Well, what's half of 14?
7.
Plus 4. Are they inverses? No. Why not? Because I didn't get my 9 back again. If they're inverses, whatever number you picked, so let's say somebody else picks 20, all right? You plug 20 in, get an answer. Put that answer in here, you need to get your 20 back again.
So on the quiz, would we make our own like blood number?
Yeah, you just pick any random number you want.
I guess so.
I would stay away from 0 and 1 because they're kind of special, but any other random number would be fine. So the question was, are they inverses? The answer is no. And they're not inverses because I started with 9, but I ended with 11. So that would be another way of saying it. If you start with 9, you got to end with 9. All right, any other questions about that one? Okay, now we're going to find the inverse. Okay, one of these we had a quiz over. When we're done here, I'm going to hand back all the papers I've got. But here's our first problem. Y equals negative 2x plus 9 over 4. The directions say find the inverse. All right, here we go. Who remembers? Marty, what's your lanyard? What am I going to do? Okay, be careful. When you find an inverse, there's a first step you got to do. Before you do any arithmetic, you got to do something first. Joshua? Yes. So we're going to write x equals negative 2y plus 9 over 4. So the first step to finding the inverse is switch the variables. Then, Brennan, I will multiply by 4. I'm trying to get y by itself. So I multiplied by 4. Now I will subtract 9. And then I will divide by -2. So I will already have an answer blank set up for you. I know this bugs some of you that you have to write it in inverse notation. I will already have that in the answer blank. And so you'll say 4x minus 9 over -2. Does anybody have a question about that? Elijah, you got a light in your on? You don't have yours? Okay,
It's a 2.
huh? -2, yes. That's -2 from here. Divided by -2. All right, the next one is what we took a quiz over. So hopefully you remember how to do it. If you don't remember how to do it, hopefully you will practice it because this is going to be a test question. So there it is. This is question 8B. So I already plugged in y, I did that. So now I have to switch my variables, so x equals 3y minus 5 and 2y plus 4. Remember, every x becomes a y. Every x becomes a y. Okay? Now what? Multiply this over to here. And because it's a quantity that I am multiplying over to here, it's the denominator that comes over. Now I'm going to have to distribute. This is the tricky part. What do I have to do now? These two have to change places because I need to be able to factor out a y. And I can't factor out a y unless they're both on the same side. So I'm going to subtract that over. So I have 2xy minus 3y. Subtract this over, negative 4x minus 5. Now I can factor out my y. And divide by the parentheses. So y equals, or the answer blank will say f inverse equals negative 4x minus 5 over 2x minus 3. This is probably the easiest question on the test. Your job is to find x, comma, y. X is t squared, but we know t is negative 1. So x is going to be negative 1 squared, which is 1. Y is 5 plus t over 3, But again, t is -1, so y is gonna be 5 plus -1 over 3, which is 4/3. Done. It's a plug and chug. You don't have to memorize anything, you don't have to know anything, you just plug it in. And that gives you your point. All right, 10 is a 4-part question. I would suggest that for this one, you label the points on the original picture. Because what we're going to do is graph the inverse. Okay? Now, before we graph the inverse, let's answer B, C, and D while we still have our picture right here. Is that a function? B says, is that a function? Yes, because it passes the vertical line test, doesn't it? Is its inverse a function? No, because it fails the horizontal line test. Doesn't it fail if you draw across there? So is it 1-to-1? No, because if it's 1-to-1, it has to pass both tests, and this one doesn't pass both tests. So B, C, and D are easy. Vertical line test, good. Horizontal line test, no. Therefore, not 1-to-1 because you didn't pass both. Do you understand that part of it? Now we have to do A, part A, which is actually graph the inverse. This is not one of your transformations like a sideways flip or a bottoms up or something. This is literally switching the X and Y. So when I go to graph this thing, this point right here becomes 0, -4. That point becomes -2, -3. -1, -2, -1, -1, and 0, 0. So there's that part of it graphed. 1, 2, and 0, 3. There is the inverse. That's a graph of the inverse. How do you graph an inverse? You flip-flop the ordered pairs. Now, this next one, I did not do a good job of outlining the axes, so I'm going to draw it up here so you can see where the axes are. Because in order to do this problem, you have to figure out what changed. So what changed getting from here to here? What changed in your picture? What?
Flip
It flipped. Didn't it definitely flip sideways? And it also flipped
upside down.
upside down. So how would I write my equation? You're doing it with F's. Yeah, you're doing it with F's like this. What would flip me sideways and upside down? What do I need to do? What's that equation look like? There's a negative out in front. That flips it upside down. And negative X flips you sideways. Perfect. So that's the answer to the question. That's a little bit tricky. So it'll be on the test, you know it will be because it's on the practice test. So when you look at your two pictures, first thing, figure out what changed. And then remember how to put stuff into the equation to make those changes happen. Okay? All right, that's our first practice test. Done. We'll work on the other one tomorrow, or the second one tomorrow. I'm gonna hand back everything I have. And